I'm Jacob. That's my Twitter handle and that's my site if you want to check it out. And I'm here to talk about testing web APIs. And of course now you're wondering, why is this guy wearing a bow tie at the technical conference? Well, maybe it's because it's Easter, so you have to look nice for Easter. Or maybe it's because I'm just very happy to be here, to meet all of you, to get the opportunity to be standing here. Or maybe it's just because I'm a strange Swedish guy. So, yeah, I'm from Sweden, and how many of you have actually been to Sweden? Oh, quite a few. But for the rest of you, I guess you've at least seen something on the internet or something. And in that case, you think that Sweden looks like this, like old buildings and yeah, nice cute cities and so on. But in reality, it's more like this. Like these large men with furs, always complaining about the fact that winter is coming and so on. So that's the world I live in. And I mainly work with startups. I've been doing startups all the time. It's my big loss is that I've never been at a large company, so I have no idea what that is like. And I've worked at a couple of companies. The first one, BERT, we really dealt with large data, like in the introduction. So I'm used to building systems that have to deal with a lot of data and have high uptime and so on. And then I left that one to start another company called Touch and Tell, which dealt with really small data instead. And we had to bootstrap from the very beginning and like do everything from the start, no help. Not even someone to code with, so it looked like this most of the time. And now I'm at a new company called Fishbrain, which is a lot like, you could say, Foursquare for fish. Or not so much for the actual fish, but more for the people who are fishing. So they check into places, they can find locations to go fish. And then when they catch something, they log like how big was the fish, what bait did I use, what was the weather like, and so on. And we aggregate all this data and figure out how to actually catch fish. Like what's the way, where should you go, under what conditions, what should you use, what's the strategy for catching this fish, kind of. We have 250,000 users right now and almost 100,000 catches locked in the database and so on. So it's growing really fast. Oops. This is a bit eager. So yeah, the fastest, easiest way to log and share your fishing. So if there's actually someone in here who's fishing, then check it out. But we're not here to talk about fish. We're here to talk about testing web APIs. And what I mean by that is, of course, that you as front-end developers, as I guess most of you are, probably touch both the server at times, like with PHP, JavaScript, Java, whatever, and also the client with JavaScript and HTML and those things. And this is like the interface between, right? So we know that what the client is communicating with is doing the right thing. And it's a big topic. So I've narrowed it down quite a bit. But of course you can ask me all kinds of questions afterwards if you're curious about other things than what's in the presentation. So, I don't want to make this into a tutorial where I stand here and recite some blog post or something. If you want to read up on something, it's easy to do it just yourselves. I want to show you something that's harder to come by reading a simple post. So I'm just going to say that to start with, I typically use these tools for writing tests of my APIs, and these are all JavaScript tools because you know I'm a JavaScript guy. Is a testing framework, Simon is a library for writing mocks and stubs. Chai is for making a nicer, easier syntax for actually writing the assertions. And Request is a library for making it easier to actually do HTTP requests to your server. So that's like the basic setup. And I'm not going to go through how each of these works. You can just go to the site, take 5 minutes, read about it. It's really simple. But if you do, you kind of would want it to look something like this. And I'm using a blog as example. If you were here last year, I used a blog as well, so we're going to stick on that theme. So, can you read it, first off, in the back even? Is it hard? Can you see it? Hands up if you can see it. Ah, yeah, that's good. Good. Okay. So what we have here is just a simple test. It says that we're going to test a blog, and the purpose of this test is to check if we can calculate the number of comments across all posts on this blog. So we have to kind of set up the stage first, and then see if the number of comments are right. So if you just look at it, you can see that first we're creating a blog with the name my blog. Then we'll create 2 blog posts. See my first blog post and then another one using the ID from the blog. And then after that we create some user in the middle, like Donald Duck. And then we create 2 comments from that user on the 2 posts that we just created. It's like very, very straightforward. Nothing weird going on there. I hope it looks simple. And in the end, we run a GET request to the blog to get the final blog, check the number of comments, and assert that it's actually 2 posts. Oh, it's way down there, so if you can't see it from the back, it just says assert equals blog dot number of comments, and then it should equal 2. So that's the way we want tests to look like. There is nothing weird going on here. It's super easy to read. It's very straightforward. Just top down, super simple. But can you actually do this? Write it exactly like this? No, you cannot. It doesn't work this way. And it's kind of weird. But why? Why can't we do this in JavaScript?
Because it's in Chronos.
Yes, exactly. We would have to write this code like this. It's exactly the same code, but we have to wait for every call. Like the first post of the blog, we can't just return a value and use the ID right away to create the next blog post. We have to type callback, wait for it to be invoked, and then use the blog. And then keep doing the same thing for every entry that we create. And suddenly this test is not very readable anymore, right? It's kind of hard to change. And if you have to add some call in the middle, you have to indent everything again and make a huge change to something that should just have been a single line somewhere. And then you might ask yourself, of course, then why are we using JavaScript? Because it seems like a really stupid language. But why would we want to write code like that? Well, we don't. Exactly. So, why do we use JavaScript then? Or why do I use JavaScript? Because maybe you're not doing it yet. Does anyone have an answer for that? Except for me being a little crazy.
There's nothing else.
Sorry, there's
nothing else probably.
Yeah, but this doesn't. It is right. Exactly. We could run this in the browser, but we don't necessarily have to run this program in the browser. We could run it on Node.js on the server, and in that case, we could have used any language. So sure, if we want to run a test in the browser, then definitely. But there's another reason as well. Yeah, I guess.
Maybe you're too lazy to learn other languages.
That could also be it, but there's a good reason, not just a bad reason. If I ask it like this instead. Everyone wants tests to be fast, right? We don't want to wait for the tests to run. And what's the bottleneck here? What's keeping the speed of this test down? Yeah, the requests. The source code, the CPU cycles, it's like nothing in this case. It doesn't matter. If we would have written this in C instead, it would be just as slow. It's the network latency of actually asking our server to do these things. That's slow. And then you say, well, I can run the tests on my server, so I don't have to wait for the network. But then you have to wait for the database. And then the database is slower. And sure, the database is not that slow. Maybe each request takes a millisecond or so. But it still adds up. And we want to make it as fast as possible. So then we kind of ask ourselves, could some of these things be done in parallel? And of course, the first 2 blog entries and the user, we don't have to wait for them to be done before we create the user. We don't have to create the blog posts after each other. We can just create all of that at once, and then create the comments, when we have the users, and when we have the posts, and then when we have the comments, then we can check the log. So it's like 4 operations instead of all these 7. If we did it in parallel. And how would we do that? I mean, if it was another language that we chose because we don't want this asynchronous JavaScript strangeness, then we would have to use threads, or we would have to do some other thing to actually make this parallel. And that would complicate our tests too. We want the tests to look like this. Just very straightforward, but very fast and very readable. This. Or maybe you want to do this, then you should use a slow language. But if you actually want to be productive. So, if we just look at what Node and JavaScript itself, for that matter, is built for, or well, this is what Node is built for. So, it's built for easily building fast and scalable network applications. Yeah, sure, that's not what we're trying to do right now, but yeah. And it uses an event-driven non-blocking I/O model that makes it lightweight. No, wait. Non-blocking I/O model. That's what's causing the asynchronous failure. That's why it's asynchronous. But it's not just a burden, right? There must be something good about that. How can we use that in a good way? And that's what we're going to look at now, today. I'm going to show you how to maintain this readability at the same time as you're maximizing the performance without making the code look weird. And if you want a second option, if you don't want to do what I'm talking about now, then use another language by all means. But don't do the nested callback thing, because then I'm just going to go like this. No, don't do it. Don't do it. It's the wrong tool if you use it that way. So the subtitle I came up for this presentation is that it takes a promise to remain sane. So this presentation will actually be a lot like a Family Guy episode, where, in the beginning they're off doing something, they're in the theme park or whatever, and then the whole episode ends up being about something completely else. It's not like coherent. They're not doing the same thing during the episode, and when everything's over, you have no idea how it started. So don't be surprised if we can't cover everything. I will just cover one sliver of this. Like I said, make the test run fast and make the code readable, because that's what I think is the main problem for people. Deciding how to test and what to test. That's a big problem as well, but we simply don't have time to cover that today. And the bonus for choosing this approach is that you can actually use these ideas for other things than testing, even though I've found that they are very, very applicable in testing and a lot easier to try out in that context, because your tests are isolated from the rest of the code. So hopefully you're prepared now for what will happen. So let's go back to the example. Well, this is a slightly larger example than I had before, just to show the complexity that it can arise. So what we're going to do in a couple of different ways, I'm going to show you the bad ways, and I'm going to show you the ways to improve it, is to create this blog, create 2 blog entries like before. This time we're going to create 2 users, and then add 3 comments from a combination of those users on those blog posts. And then check if the number of entries and comments are correct. Right? Simple, just as we did before, just a little more stuff. And before we start looking at actual code, let's say a few words about promises. How many of you have never heard of promises before? That's good. So a lot of people have. That's really good. And this is why I'm keeping this short. Just to summarize it, to boil it down to the essence of what promises is that imagine that we have a function like this on the client side in the browser. We're getting some JSON from some URL, and we're passing a callback that deals with the data when it comes back to us. That's the typical way we do it in the front end. And promises is all about detaching that callback from the invocation and be able to add it on later. So we get the JSON in this case, or not actually JSON, we get an object, the rainbow, representing the result that we want. But it's not the actual result. It's just an object that has a then function. And you can pass your callback to the then function instead. So it's pretty much the same. We've just separated it into two pieces. And then, of course, people start thinking, like, why is that useful? It seems like an extra step, totally unnecessary. But if you think about it for a while, the point is that you could add some operation in between here to do something with the rainbows that were returned. And the original invocation, the call to getting the rainbows, and the final processing for that matter, none of them have to be involved in this pre-processing, in this middle layer where we're doing something. If we were to do the same with the top example, we would have to change how we're calling it. Somewhere we have to add a function inside of our callback or wrapping the getJSON call. This way we can detach it and make it more composable. So it's a good idea because it loosens up coupling in our program. We're not making everything dependent on everything in the same sense. And it also has superior error handling, which I won't be able to talk about now, but if you haven't heard of it or don't know how it works, you can ask me later. And the main point, of course, is that it will help us to simplify the async parts of JavaScript. And best of all, it's not just that it simplifies it, because that's what all tutorials and everything about promises have shown you if you've read anything. But the real benefit is that it can abstract away those temporal dependencies, fancy words here, that you have in your programs. Our program has dependencies on the order that things should happen. The blog itself has to be created before the blog post, right? The user can be created before the blog post. The comments has to wait for both the user and the blog post, and so on. We have dependencies in which order things has to happen. And the way we solve that in regular languages is that we just do the first thing first, and then the next thing, and so on. But then we don't get the benefit of running things in parallel. We run all things in series from top down. Promises can help us abstract away that completely, so we don't have to think about the order that we're doing things. And that's what we're going to see. So that's kind of enough of the promises 101. That's the essence of promises, and I'm going to talk about how to use them, not how they work. That's something we can look at yourself. And the reason I'm speaking to that is pretty much because promises are not that new. I mean, most of you have actually heard about it before. There are tutorials in all kinds of places. This text is small, so if you can't read it, just look at the slides later. There are tutorials everywhere, and there are libraries everywhere, and yeah, there's tons of resources. They've even made it into the specification of the next version of JavaScript that's actually already implemented in Chrome and Firefox, for example. So you can use it natively, you don't even need the library. JavaScript is evolving this way. It's something that you should investigate and try to understand, because we're getting there. And we're at the very, very beginning of it now, so of course we're a bit early, but it's nice to be early. But my question to you is, yeah, sure.
Now we'll have a bunch of incompressible promises in different browsers and in different libraries.
Yeah, well, that's the point of standardizing it, of course, that there will be a single standard of how it works, and the browser will provide it according to the standard. But sure, there are different implementations now. For example, the jQuery one is the worst. It's not actual real promises. But all the sophisticated libraries out there can convert promises from a bad format to a better format. So it's actually not that hard to deal with it. And in a few years, like say 2 years or something, this will probably have been all cleaned up and they will look the same. Enough, similar enough at least. Maybe not in IE. But my question to you then is, if they're already here, Why are you not using them? Or we could do a show of hands again. How many in here would say that you are actually using promises in your code? Yeah, that's good. It's quite a few, like 20, 30 people. So you don't count in this case. I should ask the rest. Why not? And I have a theory. You don't have to answer. But I'm glad that so many actually use it. And my theory is that a lot of tutorials have the same structure. Because a lot of people like to write tutorials and blog posts on things and so on. So it's like this tutorial on how to draw down. Seems like a lot of people understand where I'm going with this. And this tutorial that I saw was in 2 steps. 2 steps to draw. The first step is that you draw some circles. And then you draw the rest of that. Right? Now everyone can draw a line. And that's the way these complicated topics are treated in tutorials. They show you like, yeah, this is promises, you have a then function, and then you pass your callback in there, and yay, now go draw the rest of that. Like they don't really tell us how to actually use it, what the real benefit is, how you should write it for real. Because we want to go out, we want to do the full thing. We don't want to mess around with some circles. And I took this example from the first announcement of promises from, I mean, the announcement that they were to be implemented in ES6 by Google. And they had a long blog post about it, and then they had this example of how nice the code became when they used promises. They had a piece of code that was twice as long, that didn't use promises. And of course, this was a lot better, because now it's shorter. I can't show you the longer one, it will fit on the screen. But does this look easy to you? Is this like, now we've solved everything? It's so simple. It takes a while to understand what's going on here. We're still nesting. 1, 2, 3, 4 layers, and 7 times. Come on, that's circles. That's not telling you how to draw the owl. That's telling you, yeah, draw some circles. And then I have another favorite example of the Node.js WebDriver, which is for controlling Selenium, like if you do UI testing and so on. And this is before promises, how their tutorial or how their examples look. It's quite readable, even though it looks weird. But we create a browser, Chrome in this case, and then we go to some site, it's guineapig.html. We get the title from the browser, we check that the title includes VD. We get an element by ID, we click that element, and we have some JavaScript. It's straightforward, it's readable quite quickly. Then they also have support for promises, and they tell you that, oh, now you can use promises. And the code will look like this. Yeah, we got rid of the indentation, but look at all the noise. Like it's then function, then function, then function, then function, then function. Half of the lines are then function. Do I really want to write that all the time? Does this make sense? And I have to add return statements where I didn't really need them before. The amount of code is like doubled or something. So what used to be callback hell became then hell. And that's what all these tutorials are doing. They're introducing you to this then hell, which is all these circles. And it reminds me of the movie Dude, Where Is My Car? If you've seen it, like when they try to order Chinese food. The machine keeps asking them, like, okay, you want rice? And then, yeah, we want chicken. And then, yeah, some sauce. And then, no, we're done. And then, no and then. And then, no and then. And then, no and then. And it feels like that when we're writing our code. It's like, so stupid. And no one tells us how to actually do it. From WebDriver are just 2 different ways of doing async. We can do all the nesting, or we can do all the and then. And it's still uncomfortable. It's still not as nice as writing the code in even PHP. It's still circle tutorials. So they missed the point of promises, which in my opinion is to make the async code as straightforward as the sync code. Not better, not halfway. It should be just as straightforward, the same. And that's possible. We can write code that looks like the first example I showed you, the very first code example, using promises. No callbacks, no thems, but still work. And that's what everyone's missing. So, to do that, we have to do three things. And the first is that our functions should return promises, not callbacks. And that's what everyone got right. That's what all the tutorials are about. Like, yeah, you can get rid of these callbacks and I'll use them instead. Yeah, okay, good. They missed the other two, which are that our functions should accept promises as arguments, not just return them. That's the most important one. And then the third one is that if we want to write code that is non-trivial, we want to write something that's a little bit complicated, then we also need some way to augment these promises in the same way that we augment regular objects. And what I mean by that, I'll get back to. So let's elaborate with an example. And you already know which example. This is the one we're going to look at. The blog, the two blog entries, some users, some comments, and then check the stats on them. It's going to be quite a lot of code on the screen, but it's just doing this. So you don't have to read each and every line, you just have to look at it to get a feel. And I've also put all the code up on GitHub, so if you want to check it out later, and like really understand it, sit down and read it, then you can check it out. I'll give you the link. So now just try to get a feeling on it. I even added it in the presentation, but you can't read that, so let's jump to this. Now I can see what we try to make it anyway. Is it readable in the back? Should I make it larger? Yeah. It's good. Okay. So this first one is just it's the trivial one, with all the nesting. So we create a blog using some post function. I haven't defined these because I guess you kind of understand what they do. We just pass some data to a URL and with that post request. So yeah, we create a blog. Then we create the first blog entry. And I used a helper function here that I call concat URL that just takes any number of strings or numbers or whatever and concatenate them using slashes to create the URL. So we create the first post there. Then we do the same to create the second post. Then we create user here, create the second user. And we create 3 comments with a combination of which visitor and which entry. Visitor 1, entry 1, visitor 2, entry 2, and so on. And the level of indentation here is just crazy. And then we check with a get function on the blog with the ID that we created. Does the number of entries and comments equal what we expected? Yeah. Nothing strange here. It's easy to read, but it's a bit convoluted. So what we could do instead, the comments I've written on the top is something that you can use when you look at this yourself if you're interested, to just remember, and yeah, I'm not going to read it through right now. So what we could do is to use some library that helps us to do asynchronous operations, like the async library, for example. How many people in here have seen that or used that? A few? Yeah. So that's a library that, for example, has a function called for each, and it takes an array of whatever, and then for each element in that array, it runs some operation, in this case, this code, in parallel. For every element in that array, it does all of those things at once, and when it has completed, it returns to its own callback, like this. So what we're doing is that we're creating the block, and then we create some object here with all the entries that we want to add. like the first post and the second post. And then we say in parallel, create those posts, blog posts. And when it's done, we continue. So the good thing here is that we could create 5 blog posts instead, and just add them to this object up here. We wouldn't have to indent 5 times and just add more things on. This is an arbitrary number of things, and it's being done in parallel, of course. And we do the same with the users. Just add a list of users we want, and then for each of these users, in parallel, post these. And then when users are done, we create the comments in the same way, do it in parallel, and then we check if the blog was created as intended. Starting to be a bit more complicated, right? We're trying to be smart about how to optimize this and adding lots of code to make it faster. And this is faster than the first example, but it's definitely not as we do. I think we all agree with that. But we can still make it a bit faster because we waited to create the users after we created the blog posts. And that's not necessary. We could create the users and the blog posts at the same time to make it even faster. So let's try that. So the async library also has a function called parallel, which just takes any number of functions, in this case 2, and for each of those functions, it runs all of those functions in parallel, and when it's done, it returns to its callback. And in the first one, we create the blog entries, and in the second one, we create the users. So now all of those are created in parallel. And when that thing is done, we can create the comments, because now we have users and blog posts that can actually comment on. And then we do the for each again, and then we check. And seriously, this is getting out of hand. It's really hard to see that this is doing what we really intended to do. It takes at least like 3 times longer to look at this code and understand what it's doing than to look at this code, even if it's like. So this dealing with asynchronous code with these smart libraries and parallelizing things and so on, that's what Node allows you to do. But it doesn't really give you the tools to do it in an easy way. Seems like I have to speed up quite a bit. So let's go to the promise solution now. The naive one, the circles solution. I've replaced all the posts and gets with functions that now return promises instead. So it's not the same function. It doesn't take a callback. It takes a promise. But I named it the same just to make it easy. So we create the blog. We then create visitors, blog entries, and then we say we use a function that's available in all promise libraries called all, which takes a list of promises and say that when all of these have completed, then we want to do this. We want to post a comment when entry 1 and visitor 1 has been created. And when entry 1 and visitor 2 has been created, then we create the second comment. And so on. So this is a lot faster. We're doing the users and the blog posts in parallel. Very nice. And we're starting to create comments even before all the users and all the blog posts are created. We just wait for exactly the blog post and the visitor we wanted. So that's good. And in the end, we check that when all the comments have been posted, then we can see are the stats on my blog correct. So that's nice. But it's still a bit weirder. We have to add these all things. We still have a couple of calls to then it's still some nesting. These are the circles I'm talking about. So, what it should look like. If you do the thing I told you, that your functions accept promises as arguments and not just return them, then it can look like this. We create a blog, no then, just create a blog. And then we create the first blog entry by using some getter function. Because this is not actual blog, it's just a promise representing the result that we will get. And we say get ID from this, because we want to concat that with the blog, and then create strings. And do the same for entry 2. And then we create visitor 1, visitor 2. And then we can create the first comment by saying, from visitor 1, get ID, and entry 1, get ID. And same thing for the other comments. And suddenly there are no callbacks, no then. This code automatically figures out that since these arguments I'm getting are promises, I have to delay my execution until these promises has resolved, until they have the values. There is no need for me to keep saying, wait for this and this, and wait for this and this, and after this, in this callback, do this. Just pass the promises you want into the places you need them, and it will automatically do this for you. That's what I mean that when I say that promises can resolve your temporal dependencies. Time does not matter in this case. You just say what you want where. So that's really awesome. And now I have to speed up. Those are just the slides with the code I showed you. And we have gotten rid of all the tags in our code. So the two first things are now fixed. We return promises from our functions, and we accept promises as arguments. And if you've been paying attention, I haven't shown you how to accept promises as arguments. I just told you if we could do that, it would be awesome. So we've still missed one that I hope I can get time to tell you about. And it's this thing that, in the example I showed you, we were just passing data back and forth. We didn't do anything with the data. We just got some data and passed it on to some other place. And that's not usually what we do. We want to do some processing as well. I mean, that's the point of computers. We connect them to some devices, we get some inputs, we pass some outputs somewhere. That's the only thing computers can do. We have to be able to do something in between. And this augmentation of objects is kind of a sensitive topic in JavaScript because we have two options. We can extend our prototypes, or we could grab objects in a jQuery underscore Lodash kind of fashion. And to figure out which way is the best, I made you a complementary decision makers. So, if you're writing an app, no one cares. It's your app. Do whatever you want to. Send the prototypes, do some wrapping. No one cares. If you're writing a library, then don't modify the damn prototypes, because someone else depends on your library, and if everyone modified prototypes, then we wouldn't know what would be clashing, and you couldn't resolve it in your program. So in that case, you have to do wrapping. And I usually, even in my apps, I wrap instead of extending prototypes, because often I want to extract code from my apps into a library. And if I do that, I have to change the code if I use prototypes first, and then have to do wrapping. So it's a lot easier to do wrapping. And that's good news, because promises are already wrapped objects. That's the entire point of them. The promise values, like the blog we get back when we post to the blog URL, is not the actual blog. It's an object that represents the value that we're going to get. Just like when we grab something using underscore, we don't have the value anymore. We get a special underscore value that holds the object inside, and that's some function on it. So what we typically do with chaining is that we grab a list of names, for example. We say chain, so we can run a couple of functions on it to get the unique names, to shuffle them, and get the first two. And then we have to say value to get the value back out. Or we could do repeated wrapping. Wrap the names, get the unique ones, and then wrap the unique ones, shuffle them, and wrap the shuffled ones, and get the returns back. Promises already have this. You don't need a way to get the value back. If underscore worked like promises, you would have a then function in the end instead. And if you had the things I talked about before, if you could accept promises as input, number 2 in my list, then we wouldn't even have to unwrap the promises. We could just pass them in there. We wrap the names, we take the unique ones, shuffle them, get the first 3, and then pass it as argument to our function. We don't have to write them, because the way we unwrap objects are standardized. So there's no chaining explicitly. There's no value. It just looks really nice now. But of course, they don't do this. Underscore doesn't have this thing. But we need it. So I wrote a little library that I use myself that I call C. which is for doing exactly that. And helping with other things that I haven't told you yet, how to pass in the promises to our functions. So C does 3 things. It's no coincidence that it's 3 things when we need 3 things to actually make promises work. So we have deep resolution, promise-friendly functions, and augmentation for promises. I think, just to warn you, I need 5 more minutes, if it's possible. 3, okay, now we do it really quickly. 1 minute per bullet here. So the deep resolution, the first part it does, is that if you pass promises into an object, or an array, or something, you put promises inside something, like this data object, and you wrap your object with C, then it becomes a promise, which will resolve when all the promises inside it have resolved. So you can actually use them. And this goes deep, so if you have arrays inside an object, whatever, it will just resolve the whole thing. And then it has 2 functions, called bind async and bind sync. And the bind sync function, async function, it takes a function that has a callback, like our post method, which takes a URL, some data we want to post there, and a callback. And if we pass post into bind async, we get a new post function back, which now returns promises and accepts promises as input. So it's become this friendly function that we can actually use like the ones I showed you before. And the bind sync function, it does exactly the same thing, but for functions that are not asynchronous. And why that is good is that we can still pass promises into this function before we resolve them. So if we have to add 2 things, we can add 2 IDs that we got them as promises without having to write them anywhere. We just create promise-friendly functions. And then the third one is that we really don't want to do this. If we get some object, some text, and we want to lowercase it, if using promises as normal, like the circles way, we have to do then on it, and get the actual text out of the promise, and then we can lowercase it. And we don't want that. No and then. So Z has these mixes that work pretty much exactly like underscore and those libraries. So we can add a function to Z. We can say to lowercase should be a function where we take the promise, which now is represented by this dot value, and then run to lowercase on it. And suddenly, the promise down there can just use to lowercase right away, and it will invoke that function out there when the promise has resolved. That said, is never explicitly used, because we have wrap get with set already, so the promise return is compatible with set library, which is compatible with the standard to your question before. And there's even a couple of libraries built in. Like we have, there are finished libraries for all the built-ins, all the array methods, all the string methods, and so on, and all the underscore methods, and Lodash and other libraries. So you can just add them with a one-liner instead of translating all methods to promise versions. And then you can use, for example, 2 lowercase from the standard library and first from underscore. And suddenly we have all these things, and we don't have to think about these async things anymore. The code becomes flat, and it's as straightforward as a sync code. Now and then, it only takes promises to remain safe. And that's it. Thanks.